Hi everybody, home stretch. I'm here to talk to you about mammals, and not our more popular one, the finigi, but some with maybe more of a mixed reputation, the non-native mammals. And we've got a lot of co-authors there because this is kind of a compilation of information from a couple of different projects. First, I wanted to set up the context of why these studies are important and why it's important to really discern the functions of these different species. We could treat them all as just, oh, they're all natives. We don't need to understand that much about them except that we need to get rid of them. I wanted to kind of introduce this term that's tossed around in a lot of ecologist communities, novel ecosystems. And so these are systems with species assemblages that are historically unknown from that area. I think people first started using them to describe places like abandoned plantations. So highly modified areas that have usually a mix of both native and non-native species. And they usually arise through anthropogenic causes like species invasions or other environmental change. They also describe probably a majority of the ecosystems on Earth, so it's important to think about this context. And finally, I think it's a good way of describing the habitats in Guam. So I wanted to give a little bit of background on how these mammals got here. Philippine deer were introduced to Guam by a Spanish governor between 1770 and 1774 for hunting, and it quickly became a popular sport, as evidenced by these wood prints from expeditions in the 1800s. I couldn't find any artwork on old rats or pigs, so if anybody knows of any, please let me know. And pigs were introduced with Spanish colonizers, but we believe that Polynesian rats arrived likely with the Chamorros, and that other rats like Norwegian rats and the shrimp rat, which I'll focus on a little bit later, likely arrived with European explorers. So first I'm just going to focus on ungulates. So we'll scrub away that little rat there. And that's deer and venado are kind of the big players in the limestone forests. Venado and bogwe are the big players in the limestone forest here. And this is work that I did for my master's thesis here in Guam at UOG. And to better understand the ecology of deer and pigs, I focused on 3 questions. First, basically, do they kill seedlings? Do they disperse seeds, which is important in the context of Guam because we've lost a lot of our native seed dispersers? And then finally, kind of more generally, how do they affect different forest characteristics? And we're pretty sure they're having some sort of effect. And I just wanted to share a pair of photos with you that maybe a lot of the USGS folks are familiar with. This is an experimental closed snake population site in Northwest Field on Anderson, and they set up a snake enclosure, so there are no snakes moving in and out of this. They use a snake-proof fence, and that effectively excluded deer and pigs as well in an area that we know they exist in pretty high abundances. So you see this photo point over there on the right, and that's mostly kind of scrubby Stachytarphiida, non-native vegetation. And within 2 years after they erected the fence, this is that same photo point. You can kind of see it in the middle, amongst the tongue in there. So we do think that they're affecting regrowth. And when we set up our own experiments, we planted a number of seedlings into fenced and unfenced areas at multiple sites in Guam. The species we used were Mapunao, Lada, Agao, Fagot, Papaya, and Aplokating. So we had this experimental setup where there was a fenced treatment, so the ungulates couldn't get in, and then an unfenced treatment where they could get in. And then we measured seedling survival. We analyzed this using a generalized linear mixed models approach, the details of which I'll spare you. But we can see our 6 species here on the x-axis, and we found that for 4 of these species, they had significantly higher survival inside the fenced plots compared to the unfenced plots. But for 2 species, the Mapunao and the Fagot, they seem to do just fine whether they're inside the fence or whether they're exposed to deer and pigs. So the next question we wanted to ask was, do deer and pigs disperse seeds? And this experiment was pretty straightforward. We basically just went out in the forest and collected poop, and then we brought it back to the nursery and planted it, and then we watched what grew. And a bunch of things did grow. We have our native species there at the top highlighted in gray, and from left to right we have an estimate of the average number of seeds per fruit, which is kind of important in determining whether these show up in high numbers in the scats. Let's see. So what I wanted to point out here is that they're pretty small numbers from the deer scats, while we see some pretty high numbers, including from native species, within the pig scats. And we had a lot of germinants across pretty much all 30 of our pig scats, whereas with our deer scats, we had seedlings germinate from, I believe, only 1 or 2. And so another question we can ask using this data is, does this reflect what's available to them in nature? Or is there evidence that they're kind of selecting for certain species? So we can't really answer that question with certainty, but we can kind of look at this visual representation where we have the species that are abundant in nature on the far right, and I've divided them into native and non-native plants, and then the species that are abundant in their scats. And we see that there's a pretty stark difference between that. And that could be a number of reasons. It could be their preference. It could be something about the fruits themselves, whether they're fleshy and attractive to them, and whether they have a lot of seeds in them. And that would account for kind of their overrepresentation in the scats versus what's in the wild. And then finally, how do deer and pigs affect different forest characteristics? So to do this, I didn't end up doing like real ungulate density estimates. I instead used a proxy. I counted scats, so we're back to poop again. And then I assessed the vegetation of these different sites so that I can compare these kind of proxies for abundance with what we're finding in nature amongst the plant communities. And this was what we found. We saw some really clear patterns with deer abundance, where you have high total seedling abundances in areas with low deer abundance, but as soon as you get a few more deer in an area, you see these really steep declines in overall seedling abundance, which is represented at the top. And then even when you split that up into native and non-native species, you see that same kind of steep decline across the seedling abundance. And we also saw that this pattern held very strongly for vine abundance as well, compared to deer abundance. But these patterns we just didn't see very clearly with the pig scats. All right, so some takeaways from the deer and pig studies. We believe that deer are strongly linked to declines in seedling and vine abundance, so they're important in shaping what the forests look like. Pigs are capable of dispersing both native and non-native plant species, whereas deer seem to play not as strong of a role in this. And so we think that deer are probably more detrimental, at least in limestone karst forests, where we did all of our studies. And it's important to make distinctions between these species and between these habitats as well, all while keeping this kind of idea of these novel ecosystems with different species interacting in new ways in mind. And I just wanted to share what our sites look like. You can see this really sharp karst. If you've been in the limestone forest, you know that the substrate is really sharp and rocky. And what we know about the natural history of pigs is that a lot of damage they do is through rooting, and that's much more difficult to do in this type of substrate, and that's probably why we're getting a really strong signal from deer and not so much from pigs. If we did this study in the south, like in clay soils, we'd probably, I suspect, we'd find a stronger signal of pig damage. And then what about rats? So they're known to be pretty harmful across a lot of different systems, especially island systems, and they do this in a variety of ways, including direct predation, as illustrated in this photo, on birds themselves and their eggs. They can outcompete native fauna, they spread disease, and as I think Lizzie mentioned earlier, they're known to be seed predators in a lot of systems, so they can negatively impact plants in that way. But we're also curious if maybe they can disperse some seeds. And there's some evidence, like there's a study in Hawaii where rats there were able to pass at least one native and at least one non-native species of fruit with very small seeds. And so this is just preliminary work that we're starting up. Just this past summer, we started feeding trials with rats, which we trap from the wild. By wild, I mean behind the fisherman's co-op. So we fed them a number of different fruits that we found in limestone karst forest areas, and then we recorded what happens to these fruits and what happens to these seeds. And so bear with the large table here. The native species are highlighted in green at the top, and so we've managed to feed them a pretty large number of species already. And so just walking through the columns here, the number of fruits added is how many fruits we fed them. Number of seeds handled is how many seeds they kind of cleaned the fruit off of and then spat out. Number of fruits remaining are the ones that they ignored or left in their cages. And then you can notice this column with a lot of zeros in it. Those are the seeds that we actually did find in scat. And then this approximation that we made in the final column with the highest numbers is what we suspect they're actually destroying based on subtracting how many seeds we think we fed them minus all the other categories. And this is just a visual representation of that. I wanted to point, I split them up by size, and we saw that only the tiny seeded species like Pipterus were showing up in scats, but that those, this is still a very, anyway, right. This is still a tiny, tiny little blip compared to what they're destroying. So in the future, we hope to continue our feeding trials with rats, and next summer we're hoping to start feeding trials with pigs. And ultimately, we want to know how this affects germination. So we've been planting these seeds that we've been extracting from the scats, and we're going to see if it helps germination at all. And finally, I didn't mention like a really important mammal that we think are going to play probably the largest impact in all these systems. We're embarking on some social science work because, how this all plays out in the conservation world really depends a lot on people, probably more so than what these animals are doing. So thank you. I just wanted to highlight our star intern, Andrea. I kept saying we fed them seeds and blah blah blah, but she really is the one that did most of the fruit collection, scat sorting, feeding rats, maintaining them, taking care of our nursery. So thank you, Andrea, and thank you to EBL, Iowa State, and CERDOP for funding.
We have time for a few questions. Yes.
So what have you concluded on the control of deers, pigs, rats?
Well, I think it's important to remember that it's kind of a mixed story. A lot of times when we talk about management, and this probably has a lot to do with feasibility in general, ungulates are bad and we want to get rid of all of them. But we found that they're probably playing kind of different roles in these systems. And I'm not saying that pigs are great or anything like that, but when we have systems that are completely devoid of their seed dispersers, and we're thinking about rehabilitating those systems, we might want to consider maybe leaving some of these species in before we get, as we're working on getting those native birds back in. And rats, it's still to be told, it seems like they're pretty bad predators of seeds, but and if we start controlling snakes, it's something that we really need to worry about. But yeah, that's still very preliminary. Thanks for the question. Ms. Stein?
The seeds that were destroyed, do you germinate those? Or?
Oh, the ones that were destroyed?
Yeah.
So a lot of them, well, it was kind of like an approximation, right? So we didn't see all of the seeds that were destroyed, although we do see seed fragments in a lot of the scats. We presume that they get digested or the rats are hiding them to spite us, which I wouldn't put beyond them.
Were you counting the ones that like they eat around, they handle them and then they leave them there? Or?
Yes. So, yeah. No.
Oh.
So those were the ones that were handled, and we are planting those. Yeah, so she was asking if we were planting the seeds that they were like eating the flesh off of and then leaving in the cages, and we are.
One more over here.
Oh, yes.
Have you given any thought to different mechanisms through which rats may disperse seeds, catching behavior?
Oh, that's a great question. And so that is, he was asking about other methods, so not just pooping them out, but maybe they're moving seeds in other ways. And that's kind of true for a lot of other animals as well. Birds will spit out seeds, and we know in the cages the rats did spit out seeds. And something interesting about their natural history is they do cache things. Rats like to collect things and then move them to another place and kind of collect them in places. And you see a lot of like rat caches with snail shells, right? But we haven't seen evidence of like seedlings popping up in these areas, but it's something that we would like to look at.
Thanks, Anne Marie.